Okay, this is the lead screw mechanism. So the lead screw has a drive shaft that has the lead screw mechanical parts on. We have our lead screw nut attached to the outer truck with two small screws. We have 4 shaft collars, 1, 2, 3, and 4. These two hold on the lead screws onto the drive shaft so they don't slide back and forth. So this mechanism has an input type of movement of rotary, since we're turning our crank on the side in a circular fashion. The output is the truck here moving along this track, and that is a linear type of motion, since when we turn the crank, the truck only moves in one direction. The only way to get it to come back is to reverse the crank. The torque on this is increased because we have to turn this input a lot to get this to move a little bit. So we're moving this a lot and this is only moving a little bit, so that's telling us that we're increasing the torque a lot, so we're decreasing the speed. The angle of the input shaft to the output is parallel, since this mechanism is attached all onto one long drive shaft, so it is parallel. The flow of power is not reversible. Since I'm turning our crank here on the side, I cannot push this truck to make this mechanism work. So I can only turn the crank. And the direction of travel is reversible, because I can turn the crank both ways and I can get this truck to travel along the track both ways. The one other thing to note on the lead screw is that each of these lead screws should be completely put together. There shouldn't be a gap between them. And the only part that should be moving is this truck when we twist the lead screw. So if the truck does not move, it's probably because you used too long of screws here that's locking it onto the track in one of these holes.